Lesson 4.4, Parallel and Perpendicular Lines. Our objective today is to write an equation of a line that is parallel or perpendicular to a given line and through a given point. So we have already been given information of the slope and a point, and you had to write an equation. This time they're going to give you a line that's parallel or a line that's perpendicular. Basically, that is how you will find your slope from those. This is standard out. It should be A1.2.2. That must be a typo. Anyway, if you look at parallel lines, let me draw a couple. No matter where they are going exactly at the same slant. Okay? Those aren't perfect, but pretty good. They go exactly at the same slant. So therefore, parallel lines have the exact same slope. So given a line parallel, you use its slope. Now here's what's going to happen. Example A is a very typical problem. It says, write the equation of a line that goes through 4, 2 and is parallel to y equals 1/2 x minus 3. The only thing that you need from that equation is that right there. That's the only thing you need. Throw the rest of it completely away. Forget about it. Basically, what I would do if I were you is I would just say m equals 1/2 and then mark out the whole thing. Forget about that line. You no longer need it. You only use the line for the slope. Once you get the slope, you have y equals 1/2 x plus b. Then you have to use this point that they gave us. Well, I'm going to plug in y of -2 right here. And I'm going to plug in 4 for the x right here. And then you're going to solve it. So -2 equals 2 plus b. Subtract 2 from each side. And b equals -4. So my final answer will be y equals 1/2 x minus 4. You use the slope from the parallel line. You use the point they give you. And then you find b and you solve for it. All right, example B. This time they give you parallel to, they give it to you in standard form, right? That's standard form. Well, I'm going to give you a little hint here to make your life easier. This is AX plus BY equals C. Slope is -a over b. Now, if you don't remember that and you don't like that, what I just told you, you could take 2x plus 3y equals 4 and put it into slope-intercept form. But I'm going to promise you, you're going to get the same answer. So if I say -a over b, what would -a be? -2, and what's b? So the slope is -2/3. Now, for those of you that don't believe me, I need to put this in slope-intercept form. Subtract 2x. See where I get the -a? You see that? 3y equals -2x plus 4. And divide everything by 3. Y equals -2/3 x. What's that? Why do I leave out the x and y?
On A and B,
With the shortcut that I gave you? Because, well, this shortcut I gave you, it keeps you from doing what I just did right here. If you have it in correct standard form, ax plus by equals c, every time the slope's going to be negative a over b. Okay? So I don't need to involve the x and y on that. But I left the x and y here when I wrote it in slope-intercept form.
Why don't you write it up for slope?
Because the slope is the number, that's the rise over run. It doesn't have any x or y with it. It's only the number in front of the x. It's the rate. Okay, so you don't put any x with it. It's only the number in front. So slope is negative 2/3. Either way I go. Now, I use this point, 6, negative 1. So y equals negative 2/3 x plus b. Now I got to plug the numbers in. So negative 1 for y, that goes in here, equals negative 2/3 times the 6 goes in for x. I'm going to put 6 over 1 plus b. Well, good news, the 6 and the 3 cancel and become a 2 and a 1. So my equation is now negative 1 equals negative 4 plus b. All right, add 4 to both sides. And b equals 3. So then you finish off by writing the full equation. Y equals negative 2/3 x plus 3. You find the slope from the equation it gave you. Use that in the slope-intercept form. Plug in the point for the x and y. And you solve for b. So from that original equation, all you pull off is the slope, the negative 2/3. If you can remember negative a over b, then you won't even have to do that part that's in the red circle. But you need the slope, and then you don't need anything else from the equation. Ben?
So, if, let's say that,
Now, let's look at what happens when two lines are perpendicular. Perpendicular lines are going in complete opposite directions by a right angle. Their slopes are negative reciprocals. Okay, so this is what this says right here. It says slope, if an original slope is 2/3, the perpendicular slope, this symbol's perpendicular, the perpendicular slope would be negative 3/2. It's the reciprocal, you flip it over. If an original slope is positive 2, the perpendicular slope would be negative 1/2, you'd flip it over. If the original slope was already a negative, so negative 1/4, then the perpendicular slope would be a positive, and then you flip it over to positive 4. So this is kind of the same deal here. They're going to give you an equation, and you're going to take that equation and only pull the slope off. So example C says, write the equation of a line perpendicular to y equals 3x, and it goes through negative 3, 1. This is what I look at. The slope is 3. The perpendicular slope to that would be negative what? Josh? 1/3. And after you get that, you forget about that equation completely. You need nothing else from that equation. It's perpendicular to that one, so this new slope is negative 1/3. So you go y equals negative 1/3 x plus b. You plug the 1 in for the y equals negative 1/3, and for x you plug in negative 3. So 1 equals, so negative times negative makes it positive. What's 1/3 of 3? 1 plus b. Subtract 1. Uh-oh, what happens here? What's b? 0. And that can happen. That just means that it goes through where? origin. So your equation is y equals negative 1/3 x. Don't put plus 0. We don't need that. Y equals negative 1/3 x. Done. Okay, questions. They're going to give you an equation, and it's either going to be parallel or it's going to be perpendicular. Parallel, you use the same slope. Perpendicular, the negative reciprocal. And then mark that equation out. You need nothing else from it. Don't leave it around there. You might get confused. So you're pulling out the slope and a point. And you're graphing, or not graphing, then you're writing it in slope-intercept form.